Hi guys, welcome to Unit 3. Here we go. This is going to be addition and subtraction of decimals, and the whole overarching theme of this unit is using the standard algorithm. Okay, here's a word that you've probably heard before. Algorithm. The word standard means, well, kind of the one that we all use, the one that we're all used to using. The one that everybody seems to learn and makes this process easier. The algorithm are the steps that we follow in order to come to a correct answer. An algorithm is kind of like a plan, okay? I have basically an algorithm every single morning. It starts with my alarm going off, me shutting off my alarm, me going back to sleep, me shutting off my alarm. You get the idea? It's a plan that I kind of follow every morning so that I can successfully get out of bed and get ready for the day. I also have an algorithm for those delicious chocolate chip cookies that I like to make. Another word for that algorithm is recipe. All right, there's a certain list of steps that I follow to get there. In mathematics, we follow algorithms so that we can stick to the most standard and most essential and effective set of steps to come to a correct answer. And you've already learned this algorithm, or at least you probably have. If you've learned how to add or subtract or multiply or divide multi-digit numbers, meaning numbers with more than just one digit in them, then you've probably already used the standard algorithm. I'm going to briefly go over it, and then we're going to add this algorithm to decimals. Okay? So, let's check out this first. 32 plus 8. When we see it horizontally like this, it's probably not too difficult for us to put it into our heads what the answer is to this, okay? Some of you have maybe even been trained in the use of tens, changing two of these numbers into tens and switching digits around, okay? I'm not going to go over that so much today. What I am going to talk about is how this can be solved using the standard algorithm. And to use the standard algorithm, the first step is to write this vertically, okay? So I'll rewrite 32 plus 8 stacked on top of each other. All right. Now, why does it look like this? Well, the standard algorithm says that we need to put everything in its place value in columns. So this one was pretty easy. 2 and 8 are both in the ones place, right, of the number. So basically, I had to make sure that those two are lined up on top of each other in a column, okay? 3 is in the tens place, but I have no tens place here. So 3 is kind of just hanging out by itself in the tens place column, all right? Now, the other thing the standard algorithm says that if you add two numbers in a place value, like 2 and 8, and you come up with a number that you can't fit more than one digit in, like this would be 10, right? Well, I can't fit 10 into the ones place. So I'm going to put the ones place of 10, which in this case is 0, and I'm going to give the 10 to the tens place. That's why you carry that 1, because this was 10, but I can't fit 10 in there. So I'm going to put the 0, because it's in the ones place, and then give the 1, which was in the tens place, to the tens place. I'm going to put it in its correct spot, okay? And once that happens, then I just add what's in the tens place. 1 plus 3 is 4. Okay? Make sense? This shouldn't be new to you. This should actually be relatively easy. Same thing over here. I want to stack this vertically in the order that I see it. So 19 is here. And if I want to, I can go ahead and say, okay, well, here's the two columns here. 9 is hanging out in the ones column, and 1 is over here in the tens column. 215 has a 2 in the hundreds column, which means it's going to be hanging out here kind of all by itself. And then the rest of it fits in there as follows. And then again, we're just going to go ahead and add down the columns. We always start with the right-hand side, because if we have to give something to the next place value, it makes much more sense to do it that way. We can't actually add something in the hundreds column and then give something to the tens column. That doesn't make any sense. So we do go from right to left. 9 plus 5 is 14. 4 is in the ones place of that number, so I need to give the 1 to the tens place. So I'll put it on top there. So 1 plus 1 plus 1 is 3. And then 2 is all by itself in the hundreds column, so we just bring it down here. Okay? Are we good with that? Because now we're going to put some decimals in there, okay? I'm going to kind of mess these numbers up a little bit. Underneath what we just did in your journal, go ahead and write these two sentences one more time, okay? And this time, I'm going to put a decimal place right here. So it's 3.2. And over here, I'm going to put a 1.9 and a 21.5. Okay? Now the numbers have changed. Their values have definitely changed. And the place values for each of those digits, with the exception of 8 here because I left it alone, have also changed. So if I were to write this as a horizontal addition problem, here's 3.2, and this time I have a 2 in the tenths place to the right of the decimal point. And this 3 here is no longer in the tens place, it's in the ones place. Okay? 8 remains in the ones place. So instead of putting the 8 under the 2 here, which doesn't make any sense because 8's not in the tenths place, we're going to keep it in the ones place. Do you see how that kind of shifted over there? But I still have those columns going on. I have a column going right through the decimal point here, and that is the tenths place. Okay? Everything that happens in here is a tenth. Okay? And everything that happens in here is in the ones place. So this time, I'm not adding 2 to 8, I'm adding 2 to nothing. In fact, if there's a blank space here, if it really helps you out, you can go ahead and just fill that in with a 0 to show that there's nothing there. And now 2 plus 0 is 2. And 3 plus 8 over on this side and the one side is 11. And we can go ahead and just write it as 11 because we know this is the tenths place here. Now remember that there was a decimal here, so I have to put it here as well. So when I added those two, I get 11.2. Okay? Over here, I have 1.9. And again, I can go ahead and make that column right here, just so I can remind myself that this is the tenths place. And then I can fit in 21.5 as it fits. Look at this. Here's a 0.5, so I know that that's going to go here in the tenths place also. And then the 21 comes over here to the left side of the decimal. I have a 1 in the ones place and a 2 in the tenths place, or tens place, sorry. And if I add these two together, 9 plus 5 is 14. 14 tenths, okay? Now if I have 14 tenths, that means I have more tenths than there are room for tenths. Does that make sense? In other words, I can only fit 4 tenths in here, and those 10 other tenths equal 1, okay? Because 10 pieces of something, I put them together, and that gives me a whole right here in a decimal system. So 14, so the 4 stays here in the tenths because those are actually tenths, but the other 10 will be represented in the ones place as 1, okay? And now in the ones place, I have 3 ones, so I'll just add those. And 2 is hanging out here in the tens place all by itself, so I'll just bring that down and make sure that you also write that decimal straight down the line, okay? So again, this is not really anything new. The only thing that you have to make sure you're paying attention to is that everything is in the correct column. And notice that all of the decimal points are neatly lined up, okay? That's important, and it also makes your life easier. Let's look at subtraction real quick. And I'm going to go ahead and just write this vertically Well, no, I'll write it horizontally first so that we can make sure we are solid on putting these vertically. Let's say that I have a number like 37.09, and I want to subtract 2.4 from that. One of the interesting things about the United States currency system and the Canadian currency system, and I'm sure there's some others out there, pounds, euros, is that we use decimals. You'd be amazed how many countries are out there actually that don't use decimal systems because they've set their base values, their unit currency so high that they don't really need to worry about this. A good example of that is Mexico. They have pesos that can run way up, but really doesn't represent that much money compared to ours. They don't really use decimals that much. Neither do Chinese or Japanese or some of those other ones with really high numbers. But here in America, we use decimals. And that kind of helps with our conceptual idea of what's going on here, because we can just picture money, okay? This I can think of as $37.09. This I can think of $2, and if I were to add a place value here, and I will in a minute, that's $2.40, okay? So let's rewrite this vertically. I'm gonna go ahead and put the 37.09. Now, if you're wondering how to line this up right away, a good first step, something to always remember, is let's just put the decimals lined up. That makes it easy for addition and subtraction, right? So here, I'll put the decimal here, and then I'll just make sure I put those two numbers where they go. 2 goes in the ones column, 4 goes in the tenths column, because they just sit right next to that decimal point. I'm subtracting. Now, if it helps you, and very often it may, go ahead and start filling in these empty spaces with a symbol that means nothing. 0, okay? This could be a 0. So could this, and we're not used to writing zeros as leading like this unless it's in front of a decimal, but we can leave this one blank. And now it really looks like money, right? 9 minus 0 is 9. I can't take 4 from nothing, so I'm gonna have to borrow a 1 from the ones place. So let's cross this out. It's now only 6 ones here, and I'm gonna give that 1 to the tenths place. Now when I give that 1 to the tenths place, I basically cut it up into 10 pieces, okay? And that's why we write that there. That 1 that was here just became 10, all right? Instead of nothing on top, now I have 10 tenths. And now I can subtract. 4 tenths from 10 tenths is 6 tenths. These decimals are in a nice line, so I'll just write another one down here. 6 minus 2 is 4, and 3 minus nothing is 3. This is the standard algorithm that you probably already learned for subtraction. The only thing we did was add that decimal and talk a little bit more about what tenths are, okay? Another one. Let's try kind of a big number. Let's go with 215.719, and let's subtract 2.437 from that, okay? I have all kinds of place values happening in this number right here. I have hundreds, tenths, ones, and then on the other side of the decimal place, I have tenths, hundredths, and thousands, okay? The number in here represents 9 out of 1,000 different pieces that would make a 1. This one has a ones place, and then I also have tenths, hundredths, thousandths, okay? So if I want to write that vertically, I would just put this number. Pay attention to the columns because that's how we're going to know how we fit this one. Let's go ahead and fit the decimal point right underneath. And then I have a 2 just to the left here in the ones place, and then these 3 numbers right underneath these 3 numbers. Okay? And from here, it's just following that standard algorithm again. 9 minus 7 is 2. I can't take 3 from 11, so let's borrow 1 from the tenths place and give it to the hundredths place. 11 minus 3 is 8. 6 minus 4 is 2. Bring down that nice decimal and a nice straight line there. 5 minus 2 is 3. And then 1 is by itself, and so is 2, so we just bring those down. And when we take away 2.437 from 215.719, we end up with 213.282. What do those numbers represent? Could be anything. These are the kind of numbers people deal with when they're doing chemistry or physics or very precise measurements, okay? I have one more. Let's talk about money again. I have a $20 bill. $20 bill, burning a hole in my pocket. I want to go spend it. So the first thing I'm going to do is buy myself a large slushie for $1.99. And I think I'm also going to go ahead and take a thing of nachos there where I can just smother it with chili and cheese and really hope I don't get heartburn. And that's going to cost me $2.75. Okay? So the first thing I'm going to have to do, because I'm going to take these both up to the register, and what's the cashier going to do? He's going to push those two numbers into his register, which is going to add those two numbers. Okay? So let's do what his register would do very quickly. 9 plus 5 is 4. I can't fit 14 here. I can't fit 14 hundredths into the hundredths place, so I'm going to give 1 to the tenths place. 1 plus 9 is 10. 10 plus 7 is 17. And again, I can't fit 17 into the tenths place, so I'm going to give 1 to the ones place. 1 plus 1 is 2. 2 plus 2 is 4. I owe this cashier $4.74. Now remember, I walked in here with a $20 bill. Okay? So what's my change going to be? To figure that out, the machine's going to have to subtract what I spent from the money that I give the cashier. Right? We've done that 100 times. So I have a decimal here. I have dollars and I have cents. Okay? I have a 4 in the ones place, and I have 7 in the tenths place and 4 in the hundredths place. So I'm going to have to kind of fix this a little bit. First of all, I can go ahead and remember that I have columns here. This is a tens and this is a 1. This is also a 1. So I know the 4 is going to go underneath the 0 here because they're both in the ones place. Okay? And I also know that the decimal separates the ones and the tenths. So that comes next. And then I can go ahead and write the 7 and the 4. Here's the 7 in the tenths place and the 4 in the hundredths place. Looks kind of messy, but it's actually helping keep us organized. So what's going to go in the tenths and the hundredths place for a $20 bill? Is there any change associated with that? Any cents? No, not really. So I can fill those in with zeros, right? And put a decimal here. There's going to be a decimal in my answer right here. And now I have a whole bunch of nothing up here until I get to that 2, which means I might have to borrow from way over here, okay? I have a hundredths place with nothing in it. So if I take money from this, I can cross out all of those, and I can say, okay, well, what I basically just did there was I took a 10 away from the tenths place, and I'm going to spread it out all over there. So there's only 1 10 up here. This is going to leave me, and basically this is like a domino effect. This is ultimately going to give me 100 hundredths, which looks like this. It's a 10, okay? Or 10 hundredths, sorry. Which I basically borrowed from here, which I basically borrowed from here, which I know I borrowed from here. So it's like a backwards domino effect. Whenever you see a whole lot of nothing with a leading number, cross out all the way until you get to that last 0. Go ahead and give it 10, because that's all that can fit in there anyway, and borrow backwards, okay? This was a 10, I borrowed one, now it's a 9. This was a 10, that borrowed one, now it's a 9. This was a 10, but I had to borrow one, and that only left one left over here in the tens place. 10 minus 4 is 6. 9 minus 7 is 2. 9 minus 4 is 5. And there's only one left here in the tens place. So the cashier will hopefully count me out and hand back $15.26. Okay? I talk a lot about place value to try to give you some idea, some perspective of why we do the things we do. Now, you've probably, like I said 12 times already probably, you've probably already learned this. You've probably already learned borrowing, carrying, and basic regrouping like that. I just wanted to go over it one more time with you and help you realize that adding decimals doesn't really change anything a whole lot, okay? Don't get all freaked out about decimals until the next lesson. The next lesson is multiplication and division, which is a little bit different, okay? So go ahead and try the exercises for addition and subtraction. Go over the exercise video with me. And if you need more practice, check out the link at the bottom of this lesson. And then I'll see you again in multiplication and division.